This sample company has two web-based applications. The first is a back-office application whereby end users are authenticated using HTTP logons. This back-end application allows the employees of the company to manage the company's business. So recording things like payments, suppliers, shipping details, products for sale, order details, payments including credit card numbers, employees of the company, etc. Clearly this application supports data and operations that are mission critical to the company and should not be publicly exposed. The other website that the company operates is its own public facing website. This is WordPress that has been ported to use Oracle as a back-end database. So it's basically just a blog. This is a very simple setup. So it's got an about page, it's got some contact details, it's got blog entries, you can create new blogs, you can log in as an administrator, etc., etc. There's plenty of things you can do with it, but it's essentially just a public facing website. The big issue is that the public facing website and the employee based application both use the same back-end database. The public facing website is obviously exposed to the public. The back-end application is only exposed to a very small number of internal employees of the company. Even worse, both of the applications use the same database schema to store their data. So this is ripe for problems for security issues. Because the front-facing website stores its data in the same schema as the back-office application, which needs to be protected, then it would be great if we can exploit the front-facing website to gain access to back-office data, which should not normally be available because this is just a blog, just has blog posts about information about the company, etc. So let's try the basic, most simple thing to do: put a single quote in the search screen, because that's the only search box. Sorry, that's the only entry box we have visible. This gives us an error. This gives us lots of information. So we know the PHP function that failed, we know the Oracle error number, we know the file name, we know the line number, we can even see the SQL that was actually executed and sent to the database. You can see that my single quote ended up here, and here, and here, and here. So 4 places it was inserted. So this is ripe for SQL injection. But are there any other places on the WIS website that we can exploit? We could try the login box as well. We could put a single quote in the login box. Normally the admin page should not be visible to the public. You would normally blank it out. You maybe rename it so that it's not able to be found easily. So we could put a single quote in here. We could put a single quote in here. And again, we get 2 errors. So there are 2 queries being sent to the database. Both give a 1756 error. And a 1756 error, we can see the file number, we can see the OCI functions, we can see the 3 OCI functions were called, parse execute, and then obviously error because there was an error. And the SQL that was sent to the database is much simpler than the previous SQL. So this is a much better vector for attacking the website to do something, but it's unlikely that you're going to return any data. So if you want to steal data and read data from the back office database, then we're not going to be able to read data, because if we get some SQL that actually executes correctly but is still exploited, then it's not going to actually show any data. It's just going to show the login screen with an invalid password. So whilst the SQL might be better in here, it's not better in terms of stealing data. So we've discovered that the website is probably exploitable using SQL injection by putting a single quote in the search field and also in the login dialog box, because we got back error messages that indicate that SQL injection is possible. So let's try using an automated SQL injection tool instead, SQL map, to see if we can get a bit further into the website. So to use SQL map, you need to download Python 2.7, you need to download SQL map from the sqlmap.org website and install that on your PC, and then you need to run it. So obviously I just ran it there with no arguments, so it's not going to do anything. You need to basically give it a URL, and we can do that by putting the single quote in here, clicking search, and we get the URL. So we could actually, instead of putting a single quote in here, let's just search for Oracle instead. And let's use that as the URL, as the input to SQL map. And just paste that in. And let's just let it do everything, see what happens. So it's telling us that the URL is not stable, so perhaps that means we can inject it. If we want to proceed, then let's try, see what happens. So we've already found out that the database is Oracle, so it's discovered that by getting an error message presumably, which we haven't seen. Do we want to skip the payloads for other databases? Then yes, because obviously we know it's Oracle. We don't want to try if it's SQL Server or MySQL or whatever. So let's just try and give it everything, see what happens. So this is sending lots of requests to the website in the background, testing various different things to see what happens. If there's a timeout, then this may take some time because it's waiting for Oracle to respond every time it sends something. So let's just see what happens. Of course, this is not a public-facing website, really. This is on our internal network here, so I'm not going to make a video and show people how to hack a public-facing website that we own. This is actually running on a virtual machine on a server internally and is not reachable external, so there's no danger in exposing this to the public in a video. So the test is finished, and whilst the website is SQL injectable, SQL Map tested everything, but it appeared not to be injectable. That's not actually the case. It is injectable. It just means that this tool cannot do it. It's asking me to try and increase the risk level, add more heuristic tests, and so on. We'll give up with SQL Map at this point because it's definitely not going to break in. But we need to go and do the attack manually instead.